The same thing, we found the degree of polymerization before, degree of polymerization. So we can find the average molecular weight, right? That you see, why do we found? Because we just told you that you have made radicals, free radicals. So there are hundreds and thousands of free radicals formed. Each one of these free radicals is making an open chain, and sometimes the chain is terminated by automatically adding another free radical, or by automatically two of the chains combining together, and so on. So in one polymerization, different length chains are formed of the same polymer. Polyethylene is there, but it may be 2000, 2500, 3000, 4000, 6000, 8000. Different types of chains are formed. So therefore, we want to find an average molecular weight, so that we know that this polymer that has been formed has what molecular weight, which will be the average molecular weight. So the formula, this is the average molecular weight, and this is a summation FI upon summation FI. Mi is the mean molecular weight of each range selected, and Fi is a weight fraction, right? So this is it. Forget about bifunctional and trifunctional. This is just that ethylene is bifunctional and phenol is trifunctional. So if we are very much into polymer chemistry, we will go to functionality and so on. Functionality means the number of active chemical bonds, right? So if there is a double chemical bond, it is bifunctional. If there are triple bonds, then it is trifunctional. So for us, this is enough for now. And as to this formula, let us do a small example, and this will become much more clear to you. So this is your example, right? Calculate the average molecular weight of a thermoplastic material that has the mean molecular weight fractions for the molecular weight ranges listed in the following table. So you see, in the molecular weight range of 5000 to 10,000, the mean is 7,500, and the fraction of the chains that have this average are 0.11, right? This is given. Forget about this. This is the given data, that by chemical experimentation, they have found this, that in the range 5000 to 10,000, the ratio is 0.11. 11% of their chains are in this range. 10,000 to 15,000, 17%, 0.17. 15,000 to 20,000, 0.26%. And in any range, the average weight is the average weight. 5,000 to 10,000, 7,500. 10,000 to 15,000, 12,500. So this data is given. And of course, if these are the weight fractions, then the total should be 1 or 100%. If the total is not 1, then some data is still missing. So this data is given, that in any molecular weight range, what is the mass fraction or the weight fraction of these chains. Now, what do we have to do according to the formula? We have to multiply this by this, Fi into Mi, and then sum it. So for each one of them, 0.11 into 7,500, 825. 0.17 into 12,500, 2125. You do this on your calculator and check that this is right or not. That you multiply this weight fraction by the average weight of this range and get this number. Multiply the weight fraction by average weight and get this number. So when you get it, then the sum of FIMI, 19,550. And of course, the sum of Fi, if it is correctly done, will always be 1. So if you remember, the average molecular weight formula was sum of Fi, sigma FIMI upon sigma Fi. So the sigma Fi will be 1. So only this is to be done. And this is the average molecular weight for this material, whatever polymer this is, right? So this is how you find the average molecular weight. So therefore, you see, this is what they have done. You have done the FIMI summation and sigma Fi. This is the formula. This upon this. So 19,550 is the average molecular weight of whatever thermoplastic we were making. Okay. So here, let me take a small quick break. I'll take a pause. I'll clear my throat. You also take a pause, and we will continue, inshallah. Welcome back from the break, uh, and a small mental break. So, as an example, we will say that there is a Pakistani or an Indian woman who goes to USA for the first time, and she has joined a job and this and that. Now she is walking in the city and she is searching for a cold drink, and by mistake she enters a bar, right? You know, where hard drinks are sold. So there are lots of stools, right? Those long high seats. So she sits on a stool in front of the bartender. Now she is new there. There is a man on her right. He says to the bartender, Jack Daniels, single. The man on her left who was sitting, he says to the bartender, Johnny Walker, double. And then she said, oh, people are introducing each other. So she said, Farzana Ali, married. The joke is done. So for those of you who don't know, Jack Daniels and Johnny Walkers are names of certain hard drinks. And when you order a single and so on. But she thought that people are telling their name, that I am Jack Daniels and I am single. So she said, I am Farzana Ali, I am married. Okay, back to your polymers. Now, here we are talking of the structure of the polymers. Now, there is something called zigzag, there is something called tangled, and so on. So, let me show you on a schematic diagram, and this will be, these are the different kinds, right? Here, if you see, zigzag, right? You go there, go there, go there, go there, go there, go there, go there. This is zigzag. This is carbon, this is hydrogen. So this is a hydrocarbon chain. This is a hydrocarbon chain where the bonds go like this and this and this and this. So if the molecule forms, if the chain forms like this, this polymer is a zigzag arrangement. It is a zigzag arrangement. But then this is just a chain arrangement. This is a chain arrangement. So this is just a chain arrangement. So this could be different, right? So these are some arrangements in which the polymer chain naturally can happen. Now, some of the more famous ones, as an example, we will see vinyl and vinyl-idene polymers. Uh, right? So vinyl and vinyl-idene polymers. So rather than staying on the slide, we can go to the where it is actually shown. It is actually shown, right? So this is polyethylene. Now remember this C2H4 polyethylene. It is very, very famous. Polyethylene itself, right? So now it is polyethylene. If only this is there, then it is ethylene. But if this is there with an N and open bonds, then this is polyethylene, right? This is polyethylene. Now, if we told you earlier, if one of these hydrogens is replaced by a chloride, then this is polyvinyl chloride, If one of the hydrogens is changed by a methyl, then this is polypropylene. If one of the hydrogens is changed by a benzene, then this is polystyrene. If one of these hydrogens is changed by a CN, then this is a polyacrylonitrile. If one of these is changed by a COCH3, then it is polyvinyl acetate. So you see, with polyethylene, we can make different types of polyvinyls. We can make different types of things and we can make polyvinyls. And if it is a polyvinyl, this is polyvinyl chloride and this is polyvinyl acetate. The others are polypropylene, polystyrene, polyacrylonitrile. So they are all based on the polyethylene family. Polyethylene family can now change into polyvinyl chloride, can change to polyvinyl acetate. So if we are talking of polyvinyls, then these are the two ones: polyvinyl chloride, polyvinyl acetate. And these are some of the other polymers that are formed from the ethylene family or polyethylene family, right? Uh, Again, some of the more famous ones like polyvinyl chloride, PVC. You see, almost all of your plumbing pipes in your house, right, water pipes, if they are not iron, then they are made of PVC. So this is very famous. So you should at least know PVC. And then polystyrene and so on are used in a lot of clothes and so forth. So some you should remember, right? It is not that you are trying to memorize it, but at least some famous ones you should remember. Okay, so here, right, uh, we are talking of vinyl iodine, right? The polyvinyl iodine chloride is this one, right? Which is PVC. But then the next level is polymethyl methacrylate, PMMA. This is a vinyl iodine family, right? So we are showing you some, and don't worry again, right? We are just showing you, and any one of you who ends up in a company of rubbers or polymers, for example, in Brussels here, there is a big company called Amiantit. So Amiantit makes a huge number of polymer products, plastic products for PDO and for the police and for other departments and so on. So if anybody ends up in a job in Amiantit, then you will daily be doing polymers. If you end up in the polypropylene and so on plant in Sohar as a job, then you will be doing it. So those guys will need it much more. But if we go to any other type of job, then we will not need it so much. But of course, if we go to a master's degree and you have a materials course there and so forth, then some of these will be used more. Now, one way of dividing or classifying polymers is homopolymers or copolymers. Homopolymers or copolymers. You see, if the same unit is there, A, then this is homopolymer. Homo means same, right? But if there is an A and a B, then it is a copolymer. So if there is an A and a B, if there are A's and B's, if there are A's and B's, so you see only this one is a homopolymer. Only this one is a homopolymer. But all of these are different kinds of copolymers, where one type of polymer A and another type of polymer B combine together to form a copolymer. So this is also there. This is also possible. And if it is random, A then two B's, A then one B, A 3, 4, 5 A's, and any random order, then it is a random copolymer. If the order is alternating, A, B, A, B, A, B, A, B, then it is alternating. If it is in blocks, several of A's, then several of B's, then several of A's, then several of B's, then it is a block copolymer. And if one of them forms a chain and the other forms a branch, then it is a graft copolymer or branch copolymer, right? That one of the blocks is here and the other branch, so this is called a graft copolymer. So mono or homopolymer and random copolymer, alternating copolymer, block copolymer, graft copolymer. So these are some of the type of polymers, right? And here we are showing you, right, that if this light color is 1 and this dark color is 1, right, then this is random. 1 of this here, then 2 of this here, then 4 of this here, and so on. This is random. But this 1, 1, 1, 1, 1, 1 is alternating. But one block here, one block here, one block here, this is the block. And one chain of this one, but branches of the other, then this is a graft copolymer. So schematically, you are showing random, alternating, block, and graft copolymers. But these are not simple polymers. There are two types of polymers. One type of polymer, the other type of polymer, and they are joining together to make a copolymer. Okay. The chain reaction polymerization can also take place between two or more different monomers, right? We were talking of copolymers. So we are just trying to explain that. You see, earlier we were saying that there is one ethylene, another ethylene, another ethylene, another ethylene, and you are making a chain. But if you are doing it between two of them, then the polymerization is happening between one type of chain and the other type of chain. Therefore, you are having copolymers.